everyone, thank you so much for clicking onto the video. Today's learning objectives are to firstly understand that amides can be prepared from acyl chlorides and know that the formation of a polyamide is a condensation polymerisation reaction. Now we're going to look at acylation reactions of primary amines. So we've actually already seen this reaction before in the acylation chapter, but I'm just going to quickly revisit it. So when we react primary amines with acyl chlorides or acid anhydrides, we form secondary amides or N-substituted amides. And this is a nucleophilic addition-elimination reaction because the attacking group is the primary amine because we have the lone pair of electrons on the nitrogen which can be donated to the electron-deficient carbon to form a covalent bond. And it's an addition-elimination reaction because we're adding the nucleophile but then eliminating something off of the either the acyl chloride or the acid anhydride. So the primary amine acts as the nucleophile. And that's because of this lone pair of electrons on the nitrogen. So for example, if we had ethylamine, so CH3, CH2 and NH2, we have a lone pair here on the nitrogen, so it can act as a nucleophile. So in the example we're going to use ethylamine, and firstly we're going to react it with ethanoyl chloride. So ethanoyl chloride is the acyl chloride. And what we get is, first of all, let's draw out the ethanoyl chloride. So we have CH3, C double bond O, and then Cl. And we're reacting it with ethylamine, so CH3, CH2, NH2. And then what we form is CH3, C double bond O, and then we have NH, CH2, CH3, and then we also form HCl because we've lost one of the hydrogens off of this ethylamine, and it's bonded with the chlorine that's been lost from the ethanoyl chloride. And so what we formed is N-ethyl ethanamide. And we've called it that because, first of all, we need the N because we need to indicate where this ethyl group is. And we've got an ethyl because this group here is an ethyl. And we also have eth for the prefix of the amide because we have two carbons here and here. And now the reaction with ethanoic anhydride is very similar, but we need to remember that it's an exception. So we have the ethanoic anhydride, which is CH3, C double bond O, O, and then another carbon, double bond O, and CH3. And this reacts with, again, we're using ethylamine. And this will go on to form CH3, C double bond O, N, H, and then CH2, CH3. So we get the same product. And then now what we need to remember is that the carboxylic acid which is formed, which would be this CH3, CH2, C double bond O, OH, this actually reacts with another amine, so another primary amine. So what we get here is plus another one of this ethylamine to form CH3, CH2, COO minus, and then NH3 plus, CH2 and CH3. So we get this salt. So then overall what we have is we have the ethanoic anhydride, which is CH3, C double bond O, and then oxygen, another carbon double bond O, and then CH3. And then we add it with 2 moles of this ethylamine, so CH3, CH2, and NH2. And this will form the secondary amide that we want, so CH3, C double bond O, NH, and then an ethyl group. And this time we'll form this salt, so plus CH3, CH2, COO minus, and then NH3, CH2, CH3. So this N-substituted amide that we formed again is this N-ethyl ethanamide. So how we've got these equations, these acylation reactions, is that first of all what happens is that basically we separate off this section here. And this section then reacts with this amine, which has lost one hydrogen. And so this is how we get this bit here. This is how we get the secondary amide. Just imagine the amine being flipped round. So if we put a mirror line here and we flip it round, and then bond it with this partially positive carbon, and this is how we get the secondary amide. And then we have the rest of this molecule here, which reacts with the H plus to form what we had as the carboxylic acid here, where we had the ethanoic acid. And this is the same for the acyl chlorides as well. So what we've done is we've got rid of the chlorine and flipped over this amine, and then got rid of one of the hydrogens and bonded it to the partially positive carbon. And then the chlorine and the hydrogen from the amine have then reacted together to form the HCl. So now we're going to look at the acylation reactions of ammonia. So when we react ammonia with acyl chlorides or acid anhydrides, we form primary amides. And again, this is a nucleophilic addition-elimination reaction because this is also an acylation reaction. And this time, ammonia acts as a nucleophile instead of the primary amine that we just saw. So first of all, we're going to look at the reaction with ethanoic anhydride, which is an acid anhydride. So we have CH3, C double bond O, then an oxygen, and then carbon, double bond O, and then CH3. And this reacts with ammonia. So you have NH3, and this will form CH3, C double bond N, and then two hydrogens. And what we also form is ethanoic acid. So we have CH3, C double bond O, and OH. So what we've formed is ethanamide. And we call it that because it's an amide and we've got two carbons, so we use the prefix eth. And so how we've got this is that we've split up this acid anhydride. And so this first bit here reacts with the ammonia and this nitrogen with these two electrons then form a covalent bond with this partially positive carbon. And so this is how we get the ethanamide. And then this second bit of the acid anhydride then reacts with the hydrogen, which has been removed off this ammonia when it's reacted with the first bit of this acid anhydride to form ethanoic acid. And now looking at the reaction with ethanol chloride, we have something really similar. So we have ethanol chloride, which is CH3, C double bond O, and then Cl. And again, we're adding this ammonia. And this time we form the same thing, so also ethanamide. But this time we form HCl. And then what we need to remember is that this HCl then reacts with more ammonia, so another mole of ammonia, to form NH4Cl. So what we get is plus NH3, and so what this forms is NH4Cl. So overall what we have is, we have CH3, C double bond O, Cl plus 2 moles of NH3 to form CH3, C double bond O, NH2, and NH4Cl. And this is our ethanamide. So again, how we've got the amide is that we've broken off this chlorine here, and this partially positive carbon has reacted with the lone pair of electrons on the nitrogen, and then one of the hydrogens off the ammonia has been removed, and this hydrogen then reacts with the chlorine removed from the ethanol chloride to form hydrochloric acid, and this hydrochloric acid then reacts with another mole of ammonia to form NH4Cl. Now I'm going to quickly run through what a condensation polymer is. So condensation polymerization occurs when many monomers are joined together to form a long chain molecule called a polymer, and also a small molecule, and usually this is water or HCl. And we must have monomers with 2 suitable functional groups per molecule for a condensation reaction to occur. And we've actually seen some condensation reactions because we've seen the reaction between a carboxylic acid and an alcohol to form an ester. And this also forms water, and that's why it's a condensation reaction. Similarly, we've seen the reaction between an acid chloride or an acyl chloride and alcohol, and these react to form an ester and HCl. So this is also a condensation reaction. So now we're going to talk about polyamides. Now, polyamides are formed for a diamine and a dicarboxylic acid. And this is because normally to form amides, we need an amine and a carboxylic acid. So in order to get this amide link, this C double bond O NH, to be repeating over and over again, then we need an amine and a carboxylic acid. So we have 2 examples of polyamides. The first is nylon 6,6 and the second is Kevlar, and you'll need to know about both. So nylon 6,6 is made out of 1,6-diaminohexane and hexane 1,6-dicarboxylic acid. So we have NH2, CH2, and we have 6 of these, and then NH2. 6-diamine, diaminohexane. And then we also have hexane 1,6-dicarboxylic acid. So we have COOH, and then 4 of these CH2s, and then COH, and then O. So this is hexane 1,6-dicarboxylic acid. And these two react together to form nylon 6,6. And you'll need to remember these 2 chemicals that join together to form nylon 6,6. So again, what we do is we have the diamine and we have this dicarboxylic acid, and we have ... and then plus ... and what we're doing is, again, we're taking away a water, so we're taking away this, and this is removing a water, and so what we form as our nylon 6,6 is NH CH2 6 NH C double bond O CH2 4 C double bond O, and then it repeats, so we have NH and so on. And so from this we can see the repeating unit. So if we start here, again we scan through and see where it repeats again. And so this would be our repeating unit. And so the repeating unit would be NH CH2 6 NH C double bond O CH2 4 and then C double bond O. So this is our repeating unit for nylon 6,6. So one thing to note about nylon 6,6 is that in the lab, the reaction goes much faster if we use a diacid chloride or a diacyl chloride instead. However, HCl is the small molecule which is liberated. So we get NH2 and then CH2 and then NH2 again. And then we have this diacyl chloride instead of the dicarboxylic acid. And so what we have now is that we have that this HCl is taken away, so it's liberated. And so we still form the same polymer, the same polyamide, which is the nylon 6,6. So we still form this NHCH2 NH C double bond O CH2 4 C double bond O, and I've just drawn the repeating unit. So we still form this. Now we're going to look at Kevlar. So Kevlar is another polymer which is made from condensation polymerisation, and it's made from the monomers benzene 1,4-diamine and benzene 1,4-dicarboxylic acid. So we have NH2 and then a benzene, and then a nitrogen, and then another 2 hydrogens, and added with this dicarboxylic acid, like this, plus dot dot dot, plus dot dot dot. And you can see that this is quite easy to remember because they're both based on benzene, and they're both on 1 and 6, both of the either the amine or the carboxylic acid groups. And so the 2 monomers for Kevlar are really easy to remember. And then what happens is that we liberate the waters, and so this water becomes liberated, and so on down the line. And so what we form is we have NH, and then we have this benzene, NH, C double bond O, and then we have another benzene, C double bond O, and then NH, and then we get another benzene, and then NH, C double bond O, and etc. So this is Kevlar that we formed. And so you can see that it's really easy to remember because we just have these amide groups, so these amide links separated by benzene. And if you're going to remember it as amide links separated by benzenes, you need to make sure that this swaps on the other side of the benzene. So on the left of this benzene here, we have the C double bond O first, and then this NH. But on the other side, on the right hand side of the benzene, we have NH first, and then C double bond O. So you need to make sure that you remember that. And so working out the repeating unit of this would be if we started here, and then you scan along to see when it starts to repeat. And so this section here will be the repeating unit. So we have the repeating unit is this NH benzene, and then we have the amide link, and then another benzene, and then a C double bond O. And so this is our repeating unit for Kevlar.